Hey guys, so this is one more video that we have. So in this question, we'll be solving a question that is based on conservation of energy. Question is from the book Seaway Physics for Scientists and Engineers. So now the question says now here, two objects are connected by a light string passing over a light frictionless pool as shown in the figure. The objects of mass m1 is equal to 5 kilograms is released from rest. Note from rest. And then it says that at a height h is 4 meters above the table. Using the isolated system model, they are saying determine the speed of the object of mass m2, which is 3 kg, just as the 5 kg object hits the table. Find the maximum height above the table to which the 3 kilograms object rises. So we want the speed here. We know that height h is equal to 4 meters, and we know that the v initial is equal to 0 meters per second because the object was released from rest. So now what else do we know? We know that when the box m1 hits the table, the box m2 will be there at the initial position of box m1. So now it will have traveled 4 meters when the box m1 hits the table. So now solution, we know that according to mechanical energy, that the mechanical energy before is equal to the mechanical energy after. So now we know that in mechanical energy equation we can have work plus initially plus kinetic energy initially plus potential energy initially, which is work finally plus EK finally plus EP finally. So now we analyze our motion. We say now initially we didn't have any work done because there was no movement, and then initially we do not have any kinetic energy because our system was at rest, but we do have potential energy for box m1 due to the fact that is at a certain height h. So that means now we have potential energy which is mg h is equal to, finally what we have, we do have kinetic energy, or let's specify that this is m1 h1 because it's the potential energy of the box 1, which is at a particular height h there. So now is equal to, we do have potential energy m2 g h2, which is the potential energy of box 2 finally, because we said final the box m2 will be at the height there where the box 1 was. And then we don't have potential energy this time around for m1 because it will be at 0 elevation. So now what about kinetic energy? We do have kinetic energy for both boxes because they will be having a certain final speed just before it hits just before the box m1 hits the table. So now that means we have 1 over 2 m1 v1 squared plus 1 over 2 m2 v2 squared. So that is what we have there. And then we don't have any friction, we can cancel the work. So now what we have, we can say now in m1 we have mass, and then our mass m1, let's note down the data. We have m1 which is equal to 5 kilograms, and then we have m2 which they are saying is 3 kilograms. So that is what we have there. So m1 is 5 kilograms multiplied by g, which is 9.81. Can use 9.8 according to the the question specification. So we have h, and then our height, we said it was 4 meters, is equal to mass m2, and m2 is 3 kilograms, we are told, and then 3 is 9.81 multiplied by height h, and then h2, since we said m2 will be at the position where m1 was finally, that means we still have 4 here, and then we say plus 1 over 2 m1, which is 5, and then v1 squared plus 1 over 2 into m2, and then our m2 we said is 3, and then v2 squared. But since this is a system, we can say that now, since they are connected by a rope, that v1 should be the same as v2 because they are moving together. So now we can now simplify the left hand side. We have 5 multiplied by 9.81 multiplied by 4. That gives me 196.2 is equal to 3 times 9.81 times 4. That gives me 117.72, and then plus 5 divided by 2 should be 2.5, and then v squared, let's just say v2 squared, and then plus because the question was saying determine the speed of the object mass m2, so I'll just say v2, and then we have 3 divided by 2, which is 1.5 multiplied by v2 squared, since we said the velocities are the same. So now taking 117 to the other side, it will be a subtraction of 196.2 minus 117.72, and then we get 78.48 is equal to now 2.5 plus 1.5, that should be 4 v2 squared, and then v2 should be now 78.48 divided by 4, that's 19.62, and then taking the square root of that, we're getting 4.429 meters per second. So that's the velocity of the object 2 when just when the m1 hits the table. So now the second question says find the maximum height above the table to which the 3 kg object rises. So now we understand that when this box m2 was on the table, now it raised to a certain height of 4 meters where box m1 was, and then we said this was 4 meters, and then at that 4 meters we were saying that we've determined the speed of box m2, which is 4.2, that was 4.429, that's 4.4429 meters per second. And then now after it reached the bar, after box 2 m2 reached that height at that velocity, the box m1 will now be on the table. That means now the box m2 will be on free fall. That means under the influence of gravitational force only. So it will be influenced by gravitational force only because the box m2 is no longer pulling, is already on the ground. So now if it's on free fall, we can use the equations of motion, since now we can take that speed as our initial velocity v1, and then we can say our v final is gonna be equal to 0 meters per second, because of the moment of inertia. When the box reaches that height, it will continue to move upwards until it reaches a speed of 0 meters per second and go down again. So now we can use the formula v final squared is equal to v initial squared plus 2g multiplied by y. So our v final we're saying is gonna be 0, which is equal to our initial velocity is 4.429 squared upwards plus 2 times negative 9.81 because it's negative because directed downwards, and then we multiply by y. And then now if we're saying now 4.429 squared, that will give us 19.62 negative when we transpose, and then the other side we're left with the 2 times 9.81, which gives us 19.62y. And then can say now y is equal to this is negative, we get negative 19.62 divided by negative 19.62, that's gonna be equal to 1 meter. So after in free fall, the box M2 will travel 1 meter till it reaches a speed of what? A V final of 0 meters per second. Now the maximum height H max of the box will be that 1 in free fall plus 4, and that gives us 5 meters.